These are the oldest orogenetic movements, belong to the Precambrian times, roughly around 1000 to 3000 million years. Such orogenetic movements resulted in the formation of shield areas. The shield areas have surface areas of over 25% of the world's land area. They are formed of rocks of 570 to 4000 million years old. Our peninsular India has such rocks and mountain systems. However, long plateau of northwestern peninsular India is younger than such mountains like Cretaceous period. These areas vary considerably in height from the plateau surfaces around. In eastern Africa, they are rising about 1500 meters, and in northern Europe, they are submerged areas beneath the Baltic Sea. The East African Rift Valley systems occur where the rigid shield rocks have been subjected to pulling apart stress of this kind. The study of these shield regions, which form the geological foundations of continents, show that the process of rock and mountain formation have been effective through the period of geological history recorded in the surface continental rocks. Accumulation of sediments followed by folding, metamorphism, uplift, the intrusion of granite, and finally erosion has occurred again and again in the past geological history. Now, one of the important mountain types that we have discussed in this episode is also the block mountains. The crustal disturbances have created interesting landforms due to a portion of the earth crust breaking away or uplifted compared to either sides of the central portion getting depressed. Block mountains are a result of faulting the earth's crust, which breaks into blocks separated by fissures. When the blocks are raised high on one side of the crust plane, they form the block mountains. You can see that in the figure number 5b. There, one slope is steep while the other is gentle. For example, Western Ghats of South India. All block mountains consist of two phases. The fault face or the fault scrap, the crust of the block thrown upwards, which presents an exposed steep fault scrape, and the back slope on the gentler slope of the faulted block mountain is perpendicular to the mountain fault scrape. See figure number 5b, you can clearly see both the sides. The mountain ranges of the Great Basin of United States of America in the west belong to this type. There are Sierra Nevada is another typical example. These selected regions are surrounded by areas of comparatively low elevation. Hence, these block mountains are the centers of precipitation. Interesting landforms are associated with these black mountains, and they are horse or formed when the blocks are thrown up in between the fault planes. As an example, the Harz Mountains in Germany. The other landform associated with the block mountain is massifs. These are similar to Harz, but these are bigger in extension. These are extensive in area and less simple in structure. These are much more ancient and possesses a greater elevation. The Spanish Mesta, the central highlands and of Brittany in France, and the Laurentian highlands of North America are representative examples of this type. These are illustrated by massive fault displacements also. The areas of block mountains have grabens in rift valleys. They are formed by the depression between the two fault planes. Such rift valleys are very important, and they are found extensively in California. The Dead Sea, the Red Sea, and the Rhine Valley are the best example for this kind of landforms. The Indian rivers like Narmada and Tapi are flowing in such rift valleys from east to west.